Season 2 of the Code Like an Architect series, Abstraction in Action. Do you know why most developers struggle to understand abstraction? It's because they don't see the big picture. They think it's just an object oriented concept. If you want to know what I mean, just ask a developer what they know about abstraction and you will have answers like these. As we reach the end of this video, you will know what's wrong with these answers. While all of them are correct pieces of information and none of them is incorrect, the problem is they are only partially true. They focus on just one or two aspects of abstraction instead of presenting the full picture. In this video, you will learn what is abstraction, the elements in an abstraction, its purpose, the law of abstraction, the abstraction design principle, the four powers of abstraction, and the different shades of it. All of this backed by multiple examples and solid reasoning. Abstraction, the big picture. What is abstraction? This is entity A and this is entity B. Entity A wants to use or interact with entity B. To support this interaction, entity B may choose to expose itself as it is to entity A, or it can choose to keep itself hidden and expose only a spatialized version, specially designed for this particular interaction. If entity B chooses to keep itself hidden and expose a spatialized version for this interaction, then it has chosen abstraction. So what is the basic concept of abstraction? Abstraction is the act of hiding the underlying details from the user. Let's explore this in detail. What are the elements in an abstraction? This is the entity which wants to use or interact with the other entity. We can call it user. And this is the entity which it wants to interact with. This part of the entity represents it exactly as it exists, with all its implementation details. While this part of the entity is specially designed to support this interaction. We can call it interface. What is an interface? Interface is something that we use to interact with something, and that's exactly what it is. This element is an interface that we can use to interact with this entity. Let's look at some examples. This is Google, exactly as it exists, with all the code, servers, services, data, and everything inside Google that we don't see. And this is a user who wants to use Google to search for something. The question is, how will the user interact with it? Of course, they can't access the code, data, or servers directly. There has to be a way to interact with it, right? And that way is an interface. This is the interface that enables that interaction. That's an abstraction. Similarly, this is a car and this is a driver who wants to drive it. The driver needs a way to control the car, and this is the interface that allows them to do so. Similarly, a human wants to switch on the lights. While we know there is an underlying electrical wiring system through which electricity travels to turn the lights on, we don't want to interact with the wires directly. Instead of connecting the wires manually every time we want the lights on, we use an electric switch. That switch is an interface, and that's an abstraction. At this point, it's important to understand that abstraction isn't just an object-oriented or programming concept. It's a universal concept that you will find everywhere. Our world and our daily interactions are full of abstractions. We interact with hundreds or even thousands of abstractions every single day. Even right now, when you're watching this video, you're using an abstraction. Now, the next very important question. What is the purpose of abstraction? To find that out, let's compare abstraction with no abstraction. As we just saw, this interaction is using abstraction, and this one is not. So what's the difference between the two? The difference lies in how these entities interact. In abstraction, we are changing the way we interact. And why we are doing that? As we have seen in all these examples, we are doing it to make the interaction simple, doable, less complex, and so on. In short, we are trying to improve the way we interact. And that's the purpose of abstraction, to facilitate interaction. It's crucial to understand this purpose. Understanding this purpose will lead us to some other very important details driven by it, including the law of a meaningful abstraction. So, if the purpose of abstraction is to facilitate the user's interaction, then it's obvious that there must be a user who is using that abstraction. Abstraction is only meaningful when there is a user who needs to use the abstraction. Without that user and the need to use it, there is no point in doing abstraction at all. That interaction can be physical or conceptual. That user, they can be real or even imaginary. They can be an existing user or someone in the future. Doesn't matter. It can be a human, it can be a class, it can be a service, it can be a bot, it can be a program, it can be anything.
But there must be a user. Just like we have a user in all these examples. Without the concept of a user, there is no point in having these abstractions. And this leads to the design principle of abstraction. An interface should always be designed for the user. If all of these is being done for the user, then it must be designed for the user. An interface should always be designed for the user. Look at these examples. This is YouTube. This interface is designed for a user who wants to use YouTube to watch videos. And this one is designed for creators who want to manage their content. The YouTube app shows options like watch, like, comment, download, because that's what a viewer needs. Meanwhile, YouTube Studio app shows options to upload, edit, or track analytics, because that's what a creator needs. Clearly, these interfaces are designed based on the needs of their users. You will find this thing common in all the interfaces, and that's exactly what we need to do in programming. In fact, that is something Uncle Bob has also emphasized. See one more example. This is a car. This is the interface for the driver, and this is the interface for the mechanic. As expected, these interfaces are designed differently based on the needs of the users. At the same time, self-driving cars don't use the same interface that a human driver does. In the future, as we build more trust in the self-driving technology, we might see cars fully operated by AI with no need for a human interface at all. So in short, interfaces are always designed for users. Now, if you pause here and look back, you will notice a clear and logical progression. What is abstraction? Entity A wants to use entity B. If B exposes everything, that's not abstraction. If B hides the implementation details and exposes a dedicated interface, that's abstraction. Abstraction is the act of hiding underlying details. So, in an abstraction, we have three elements: user, implementation details, and interface. What's the purpose of abstraction? As we see, we are doing all of this to improve users' interaction, which in turn means there must be a user. And since we are doing all of this to facilitate users' interaction, it's obvious that it must be designed according to the needs of the user. Everything we have seen so far builds naturally from the foundation: simple, logical, and self-verifiable. Benefits of abstraction. The key benefits include simplicity and reduced complexity. Extensibility, which is the ability to build on top of things. Generalization, including swappability and maintainability. Each one of them is extremely powerful, which ultimately takes your programming and problem solving to another level. I like to call them the 4 powers of abstraction. These are the benefits that make abstraction arguably the most powerful programming concept. We will explore these powers in detail along with tons of practical coding examples in the upcoming videos. Now comes the most interesting part: the different shades of abstraction. Understanding these shades is key to truly grasping the concept. Missing them often leads to confusion and a lack of practical wisdom. If you look at the comparison between abstraction and no abstraction one more time, you will notice something important. The user is there in both cases. The implementation details are also present in both. What truly makes the difference is the interface. That's why we can call the interface the key element in abstraction. Now let's take a closer look at the different shades of this key element first. As we have seen, we can call it an interface because it enables users to interact with an entity, like in the YouTube or car examples. These interfaces exist to facilitate interaction. Now, let's see a different kind of example. Information in a system is stored in binary, but instead of forcing users to type in binary, we let them type alphabets and numbers because that's what they understand. We do this to make users' interaction simple and convenient. Again, it's the user who influences what the interface should look like. As we saw in abstraction design principle, design the interface for the user. So, from the user's perspective, the alphanumeric representation is an interface. But then there is another perspective. If you see it from the perspective of this entity, you can call it a high-level representation of it. And it won't be wrong either. Calling it a high-level representation totally makes sense if you look at it from the perspective of this entity. But that's not all. If you look at it from another angle, you can also call it a symbolic representation of the entity. And that wouldn't be wrong either. These are some of the perspectives of looking into this key element. Let's keep going. We can also see this in a what and how classification. what needs to be done versus how it is done, right? So when a driver presses the accelerator pedal, they want the car to drive. That's what they want. How it actually drives? That's the internal mechanics of a car, which a driver may or may not be aware of. As a user, we are concerned with what, not how. Similarly, when you press the save button as a user of a web app, that's what you want as a user. You want to save something. You don't know how the underlying code that saves your data actually works. Moving forward, in some scenarios, it will make more sense to see this as grouping or generalization. For example, when you use the word birds instead of naming each bird individually, that's an abstraction. Or when we refer to different kinds of cars simply as vehicles, these are also forms of abstraction where we are using generalization. And similarly, sometimes we can see it as a user-friendly representation of the entity, which is more convenient to the user. We can also see this as layering, just like a broker who acts as a middleman or a layer of abstraction between the seller and the buyer. These are the various forms an interface can take. And while all of them are correct, some make more sense from one perspective, while others feel more obvious from a different point of view. As we explore various examples of abstraction, you will notice that certain terms fit better in one context, while different terms feel more comfortable in others. On top of these different shades of an interface, the way the community uses the word abstraction adds to the confusion. Sometimes it's used to refer to the entire setup, while other times it refers only to the interface. But that's not all. There's even more that adds to the confusion, especially two important points about abstraction. Number one, there can be multiple interfaces of a single entity. Since interfaces are designed for users, there can be more than one interface of the same entity designed for different users or different needs of the same user. For instance, let's look at the car example we saw earlier. Clearly, the car had different interfaces for different needs. It can have even more interfaces. A car can have a screen for playing music and a remote to lock/unlock doors or start the engine remotely. These are all the different interfaces of a single car. Similarly, in our YouTube example, we had two interfaces, one for viewers and one for creators. In addition to these, suppose we want to integrate YouTube into one of our applications as developers. For that, we would use YouTube APIs in our app. All of these are different interfaces of the same entity, YouTube. In short, there can be multiple interfaces of an entity. And by the way, in many scenarios in programming, it's encouraged. Number two, there can be multiple implementations for the same type of interface. So, for example, the internal mechanics of different cars may vary from each other significantly, but almost they all use the same type of steering. Similarly, the internal architectures of different computers might differ greatly from each other, but we still interact with them in the same way. This means we have the same type of interface, but different implementations. One interface, many implementations. And of course, there is no limit to the numbers of interfaces and implementations you want to create. This flexibility of having any number of interfaces and implementations also creates various forms of abstraction when applied in practice. This is the big picture of abstraction and its different shades. The problem is that developers are often exposed to only a few aspects of abstraction, and most of the time they aren't consciously aware of the full picture. Because abstraction is such a broad concept with multiple facets, you may experience it one way at one point of time and then completely differently from another perspective later on. For example, sometimes we view abstraction from the perspective of the user, while at other times we see it from the perspective of the entity. At times, it makes more sense to think of it as an interface, while in other situations, it feels more like a generalization. Some examples are better understood through the what and how classification, while others are clearer when viewed as symbolic representations. There are occasions when we focus on the abstraction's ability to simplify and build on top of things. On other occasions, we use it to create swappable implementations that can be dynamically swapped without modifying client code. And sometimes we discuss its role in hiding implementation details and reducing complexity. When using it practically, sometimes you create only a single implementation because you're trying to reduce complexity, while at other times you might design multiple implementations for generalization. In yet another case, you can use segregated interfaces. It's very important to understand these different aspects of abstraction and develop the ability to choose the appropriate one in a given scenario. Finally, now that we have seen the big picture, it's time to revisit and evaluate the common answers developers often give about abstraction. the ones we looked at the beginning of the video. Abstraction is a way to reduce complexity by hiding implementation details. That's absolutely correct. This answer highlights the act of hiding implementation details and the benefit of reduced complexity. It's about separating what something does from how it does it. This answer looks at things from a what and how perspective. As I mentioned, none of these answers are wrong. The problem is they only give you a limited view of abstraction. It's like creating a black box that only reveals what's needed. This one focuses on hiding the implementation details and exposing only the interface. Abstraction is a technique to handle complexity by simplifying the interface to something that is easy to interact with. This definition emphasizes a simple interface and reduced complexity, while also touching on the purpose of abstraction. It's a way to generalize functionality so it can be reused in multiple contexts. This focuses on generalization and reusability. Abstraction is about defining the interface and leaving the implementation to be done later. This suggests a development approach that is specifically enabled by abstraction. Define the interfaces first. Start writing the client code while using those interfaces, and then fill the implementations later or in parallel. That's one special benefit made possible by abstraction. It's the act of suppressing the differences between various implementations and focusing on the commonalities. Again, this emphasizes generalization.
Finally, while all of these are partially correct, none of them shows the big picture. Abstraction is such a broad concept that it's not easy to come up with a single universal definition that captures all of these aspects. The problem is that when developers are exposed to one of these definitions of abstraction, they feel that they have learned it, while in reality it's only a small part. And when they are later exposed to a different aspect of abstraction, different from what they have seen before, of course it doesn't make sense, making them believe that abstraction is difficult and just theoretical. This feeling discourages the use of abstraction in practice. On top of that, the limited perspective doesn't give them enough exposure to actually use it in their own scenarios. To develop real practical wisdom, you first need to learn the big picture and the different shades of abstraction. You also need some solid exposure to real life and coding examples. And that's exactly what this season offers. While working on abstraction, I realized that abstraction is not something that I should cover in a single video. That's the reason I didn't cover abstraction in the season 1 of the Code Like an Architect series. It's not just limited to OOP. It's a broad concept and a very important one. And as you will see in this season, there are very strong reasons to believe that abstraction is the most important programming concept. That's why I believe it deserves much more than a single video. It needs a complete season. It needs a full playlist. You won't do justice to abstraction if you try to cover this in a single chapter. It deserves a full book, a YouTube book. Consider season 2 of the Code Like an Architect series, that book. Abstraction in action. And as you reach the end of this book, you will gain two things: a strong conceptual foundation that's truly important for aspiring and present architects, and the practical wisdom.